Let's do yet another question where it asks us to find the horizontal tangent, or find the points where f has a horizontal tangent. But this time, we're going to have to apply the correct rules, and there's going to be more than one rule that we're going to use. Remember, these rules do not exist independently of one another. So whenever I take this, I'm going to make sure that I look at this root as the 2x minus 1 to the 1/2. So if I leave it like this, I can apply a quotient rule, which would be fine. I can also convert this to a product, but whenever I move this up, I'm going to have to make this a negative 1/2. Sometimes working with negative exponents is not ideal. Sometimes it works out just fine. You can use either rule. You can use the quotient rule. You can use the product rule. As long as you're intentional about what you're doing and careful with the details, you'll be fine both ways. I'm going to set this up as a product because now I've got a product and a chain. Remember, this is not just a chain rule. I am multiplying x times all of this, so the product is going to trump the chain rule. So we are always going to apply the product rule, and then the chain rule is going to exist within that. So we're going to do the first. The derivative of the second requires the chain. So I'm going to do negative 1/2. Leave the inside. When I subtract 1, I get negative 3/2. Be careful with that. Times the derivative of the inside, and the derivative of the inside is 2. So that's the first part of my product rule. Plus the second, and this worked out quite nicely, the derivative of the first is just 1. So a little bit cleaner. Now I do not like negative exponents. I still don't like negative exponents. So I'm going to work really hard to make sure I can get rid of that. So these 2's reduce, which helps me out a little bit. Then I'm going to have a negative x. Let me get a different color here. I'm going to have a negative x because there's the negative, right? And here's the x value. But then I'm going to have to move the 2x minus 1 down to the denominator so I no longer have a negative 3/2 exponent. Now I'm going to do the same thing on the other side, but when I move this 2x minus 1 to the 1/2 down, what I have left up here is just a 1. Make sure that you have something left in the numerator. All right, at this point, if I'm looking for a horizontal tangent, I want to know where this is equal to 0. You can't do that unless you have just one fraction. So you have to get a common denominator here. That's what I'm looking to do. So the common denominator would be 2x minus 1 to the 3/2. So I need this to be multiplied by 2x minus 1 on the top and the bottom. How did I get that? Well, remember, I'm going to add my exponents together. So there's an imaginary 1 right here that I couldn't quite see. So 1 plus 1/2 is giving me 3/2, right? So when I multiply these together, I'm going to end up with the 2x minus 1 to the 3/2. So let's finish that out. I've got f prime of x. I still have a negative x, but I'm actually going to be adding this whole piece. So I'm going to add 2x minus 1. And then my denominator that is in common between both terms is going to be 2x minus 1 to the 3/2. This does simplify a little bit. I have like terms. So when I add negative x plus 2x, I get a really simple numerator here. So this is the derivative that I would want to work with. Remember, I'm trying to find a horizontal tangent line. So if I'm going to do a horizontal tangent line, I want to know where the derivative is equal to 0. I am only worried about the numerator. If I set the denominator equal to 0, it's going to give me an undefined derivative. So I want to know where x minus 1 is equal to 0, which is, of course, at x equals 1, very simple algebra. But to find the point, I'm going to have to plug that 1 in, right? So I'm going to do 2 times 1. I'm just trying to show you all of these steps. You're going to plug that 1 into the original function, so you end up with 1 there. So the point of horizontal tangency, right, is going to be 1, 1. If you had done this using a quotient rule, you would have ended up with the same answer. So I do not want you to think that there's only one way to do this. I was just trying to show you that that is one way to maybe avoid using the quotient rule, especially when you have a chain rule involved. Sometimes chains inside of quotients can be a little bit too demanding for us. So sometimes it's a little bit easier, even with the negative exponent. Sometimes it's a little bit easier to diagnose this as a product rule. But it's totally up to you. You still would have gotten the same answer.